Let's get on with our calculus rule, the product rule. Now, what the product rule is used for, so u and v are just different functions of x multiplied together. Okay? So when we have that situation, saves you expanding out, things like that. This is the technical way, once again, not how I do it. That's how we do it. Write down the first and diff the second, plus write down the second and diff the first. Because the challenge is, how quick can you say it? Write down the first, diff the second, write down the second, diff the first. You got to see, yeah, it's fun. You can impress people with it. But once again, if you say it as you do it, then you're doing what you say. X to the 7 times x to the 9 minus, yes, I'm sure it's probably easier to actually expand this one out, but I'm just using it for an example. So what do? Write down the first. Well, the first one is x to the power of 7, so I wrote it down. Diff the second. Oh, well, when I differentiate x to the power of 9 minus 6, I get 9x to the power of 8. Plus, write down the second. Okay, x to the 9 minus 6. And diff the first. Well, differentiate x to the power of 7, I get 7x to the power of 6. So much easier. Just write down the first, diff the second, plus write down the second, diff the first. Then let's tidy that up. And we have our answer. Now, as I say, I do concede it's probably quicker to just expand that out and then differentiate. But later on, when we look at some more interesting functions and calculate like trig functions and so on, we actually need to use this to differentiate. Let's try this one. It's a binomial. Again, I could expand it out, or I could go write down the first, x minus 2, diff the second, 2, plus write down the second, 2x minus 3, diff the first, 1. Tidy it up, there's our answer. Ooh, fancy notation, d dx. We're still doing the same thing. Write down the first, x to the 7 minus x cubed, diff the second, 6x, plus write down the second, 3x squared plus 7, diff the first, 7x to the 6 minus 3x squared. This is a really good illustration of why actually it would be quicker to expand, because if you look at it, I've still got a binomial expansion I have to do anyway in the answer, so probably more efficient to expand this sort of one out first. Expand out, tidy up, there it is. This one, it's certainly more useful to have a product rule, because we don't want to waste time expanding this whole thing down. But the fun thing about this one is it combines both of our rules, because we go write down the first, 3x. Diff the second. How do we diff the second? Anarchy. Bring down the power, lower the power, boom. Diff the inside, 2x. Plus, write down the second, x squared plus 4 to the power of 5. Diff the first, 3. Let's tidy that up. Well, mere mortal answer. Factorise it. You will notice there is a common factor there. X squared plus 4 is in both. Whenever you factorise, you pull out the lowest power. So on x squared plus 4 to the power of 4, we also have a common factor of, that's right, we also have a common factor of 3, which I haven't taken out. But that's all right, I probably do it in the next step, do I? Now we'll take it out. There it is, common factor of 3. Eventually we got it out. So 3x squared plus 4 to the power of 4, 11x squared plus 4. Why is it good to factorise? Well, what's the most common thing we end up doing with derivatives? Finding stationary points. We solve it equals 0. Well, we always like to factorise when we're solving equals 0. Oh, one with a third. Ooh-wee. Let's rewrite it. 2x times 2x minus 1 to the power of a half. Write down the first, 2x. Diff the second. Oh, anarchy. Bring down the power, lower the power, diff the inside, 2. Plus, write down the second, 2x minus 1 to the power of a half, diff the first, 2. Tidy up. We have a common factor there. We always factorise the lower power, so minus a half is going to be the factor we pull out. I'm a bit reluctant to say this, but there's also a common factor of 2. Oh yes, he took it out. So I have 2x minus 1 to the minus half. Inside the braces there, we have 3x minus 1. Mere mortal. Super mathematicians. 2 outside of 3x minus 1, all over the square root of 2x minus 1 is our derivative. That is our product rule. I can tell these things.